All right, thanks everybody. I'm going to just warm things up for 3 or 4 minutes before I do about a 10, 12-minute presentation. First off, I'd just like to ask, I like to start off, I don't want to just tell people stuff. I'd kind of like to try to talk about things people want to know. So I like to start with, raise your hand if you think you know something my office does, the Water Resource Commissioner's office. All right. Michelle, name a thing that you think my office does. All right, Michelle said wells and sanitation. You get a prize for participating, a little magnetic chip clip, but actually, the Water Resource Commissioner's office does not deal with wells and sanitation. The county does, though. The county Environmental Health Department or Division of Public Health actually does all the wells and sanitary sewer permitting. So along the lines of drinking water and the other water that you want to go out of your house, my office does not typically deal with any of that, although I do have a role in funding and financing if a municipality wants to do a water and sewer system. I see another hand up. What do you think something my office does? I'll repeat what she said, so it's okay. Culverts, she said culverts. Raise your hand if you have some idea of what a culvert might be. A culvert is a, slightly technical term for a pipe underneath a road, typically, although it could be underneath anything else, like your driveway or something like that. So the answer was culvert. And yeah, that is true. In a lot of situations, my office does deal with the way water gets across and obstructions such as a road or a driveway, right? These creeks were all here before we showed up, even before the indigenous people showed up. And eventually when someone wanted to get somewhere, they said, hey, let's find a way to get across this water. And eventually culverts got invented. So we deal with stormwater, we deal with rain, we deal with flowing water. But one thing people don't know a lot of times is the whole law that governs my office doesn't have any of that technical stuff in it. It's a process law about special assessments. So when you pay taxes, you don't pay taxes for dealing with stormwater or rain. In a city, they have an obligation and a responsibility by statute to deal with water when it rains. There's no real standard or requirement, but most elected officials like to kind of marry that up with people's expectations. In a county-wide setting and in townships, there's no one who is obligated or receives funds out of taxes to do that. So everything is special assessments. So probably 15% of the historic creeks in the county, my office has been petitioned by people who said, we got something that is so bad that we would like you to tax us more to fix this problem. And a special assessment district gets set up. Everybody whose water heads to, maybe it's a new culvert, maybe it's a storage basin to keep water in. Everybody shares in that cost, and the local municipality does too. So special assessment again means we've got just one thing we're going to do. Everybody who benefits gets to chip in and pay a share of that. So interesting thing. So I have a prize. I have some dog poop bags. Let's keep that stuff out of the water, right? Pick up your poops. All right. I know we're a little short on time. So last thing I'll say before I start the presentation, raise your hand if you went to bed last night thinking, oh boy, I get to hear an engineer talk. 3 people, just for those of you on Zoom, 3 people. And there's not 200 in the room today. So I feel like percentage wise, I'm good. So last question, does anybody know the difference between the extroverted engineer and the introverted engineer? Teresa knows the difference between the extroverted and introverted engineer. Teresa, tell me.
The extroverted engineer looks at your shoes when he talks.
Exactly. Now, I gave that answer once to my own joke in the office, and I was quickly corrected that it might be when she talks. So now I say when they talk. That's kind of my way of doing it. I'm really glad that we're seeing more and more women in the technical areas and that type of thing. I would say my office does a lot of stuff. Today, I'm just going to talk about dealing with rain and what our strategies are for dealing with climate. I'm in a little bit of a tough spot. We were talking about some serious issues before, and certainly the housing crisis is a very serious issue. And as you can see on the screen, we're dealing with lots more rain. It's raining more and more. And I guess the best way I can phrase this, if you don't remember anything else, if you have an opportunity to invest in ark building or any sort of boat building or what have you, I would encourage that. That's probably going to be a wise investment. That's the summary of my presentation. So rainfall has been going up and up in parallel with temperature. First slide was temperature. This one's rainfall. The graphs look pretty similar. The last 20 years, it's really rocketing up. Why is that? Warm air can hold more moisture. We're guaranteed it's going to rain harder in the big storms and the medium storms when it rains going forward as it gets warmer and warmer, particularly because we're a peninsula that sticks into a mass of water. So we have lots of water available. It's getting warmer. That gets pulled up into the air. So Jim, you can just keep it rolling. So Great Lakes is studied a lot. So climate change in the Great Lakes region, there's a 4-college group that looks and studies and does forecasting on this. So again, 35% more rain in the period from 51 to 2017 in bigger storms. So anything that got stuck in the ground 30 years ago, 40 years ago, 60 years ago is under-designed at this point. That's not what things are designed for today. So I'm going to talk about our strategy of dealing with more rain. We dig big holes, we dig site-specific holes, and we have a lot of people who help us out with green infrastructure. Those are very small holes. So go ahead. On the regional storage side of things, in 1968, there was a very big flood in Ann Arbor. A cell parked around this area in Livingston for a good week. It rained really hard. There was a lot of flooding in 1968. 2 dams were knocked out, Argo and Superior. 2 other dams that the city owns, City of Ann Arbor owns, were damaged. Lots of problems in the area. Lots of studies resulted in many. They look like really big holes in the ground. You probably don't see them, but most of those places where we've got a blue dot, there's going to be between a 2 to 5 acre place for water to get held up, so it doesn't all end up downstream on somebody. And they vary from 3 to 5 feet deep, 6, 7 feet deep in some places. So our goal is to store water during storms. It's raining harder and harder. It hits the neighborhoods. We want to capture that water before it gets to the bottom of the hill, because people at the bottom of the hill are going to be negatively impacted, as we've seen lately. You can go ahead and advance it. So here's one example of a regional storm back behind the High Cone area. There's a large area called Doyle Park or Mary Beth Doyle Park. My office owns the land, and we lease it to the city for $1 a year or something like that for a nice big park. And when you look at an aerial image of a community, it's a little hard to see. This presentation will be out for everybody, but there's a lot of hard surface that's get put in. And when hard surface gets put in, that means water can't soak into the ground anymore. So we're trying to hold up that water before it gets downstream, like I said. So Mallett's Creek drains about 40% of the city of Ann Arbor. 11 square miles. And if you go ahead and advance it, Jim, this is what Mary Beth Doyle Park looked like beforehand. So the High Cone area is here. The Packard-Eisenhower split is right up here for people who are familiar with the area. And this was one of the areas in many, probably a dozen studies done after the flood of 68 to build things in the mid 70s to early 80s. This was an area that was cited. This is 1968, 66 aerial prior to the flood. So next slide, Jim. They built a storage basin. Pretty solid state, doesn't do much in smaller storms. So one of our strategies is we're trying to retrofit all of these basins so they can do more work for us. If you look at an aerial image of these developed areas, you quickly see the only place to provide storage is either schools or parks. There's the only places with a lot of green space. Maybe churches have a little bit of green space too, but it's not a use that fits. So this is what we have today. We've retrofitted it so the water will take the long way, if you will. This is Mallett's Creek right here. In normal times, the water takes the long way around. Sediment settles out. We've doubled the amount of phosphorus we collect. Phosphorus is what causes these harmful algae blooms. That means you can't drink water. So, and you can just go ahead and advance it. I don't need to elaborate too much. This does more work than it used to, and you can co-locate it with a park. On the right-hand side, you see a disc golf course. There's basketball courts on the far right, and those 2 red arrows are a couple of photos we're going to show you of when it rains. The top arrow is actually a dam that's in Mallett's Creek that holds the water up and shunts it around the loop. So we'll go ahead and advance it, Jim. And that holds about 14 million gallons when it rains hard. So you can see this park is flooded. The disc golf course right now is underwater in this photo. Go ahead and advance it. And this is what's coming down the creek. I mean, this is pretty serious, and this is a pretty small rain. This might be what happens every time there's a half an inch of rain. So another place we did it, we have residential neighborhoods that today, when residential neighborhoods are built really since the 70s in the Ann Arbor area, partly as a result of that flood, every development of any substance that gets built needs to dig a hole to store water. And there's requirements for how big that should be and how often it should get flooded out. But most of our developed areas throughout the county were built before that was a requirement. Yes, plenty of things have been built since, but this is an area where they did not build storage in for stormwater management beforehand. And there's been terrible flooding. We've had to retrofit what goes on. So this was street flooding. This is well after a storm. This is a storm in 2012 where cars were floating down the streets, Delaware Street, Moorhead Street, Churchill Street. You can go ahead and advance it, Jim. So Jim, toggle back and forth on this. This is a computer model of that's how bad the flooding was. And we've dug a hole in the ground and just go back and forth real quick 2 or 3 times. So you can see, we can model how much flood relief do you get. So we did a study of the about 900 acre area that was circled there and identified 3 locations where we could add stormwater storage. The first one was built and completed last year at the corner of Scioto Church and the freeway, Scioto Church, Maple and the freeway. A couple more to be done, but this is the scale of it. These are 6-foot diameter manhole things sitting there. Things is a technical term. And there's a creek that winds through there. We've made the creek a little more sinusoidal, a little bit better habitat. It looks a lot nicer if you go out there now. All the plantings have come up and we're going to continue planting shrubs and trees over time. So that's what we can do in neighborhoods to provide flooding relief. There's additional work proposed in that area as well. Pioneer High, there's a bunch of pipes around Pioneer High and under Pioneer High. That's what the blue is. And this is what's underground underneath where all the RVs park. Look at the people and compare that to the size of the storage unit that's underneath. That small arrow at the bottom is pointing to a 6-inch diameter hole. So you can see there's rows and rows of holes. We found an area of sand underneath Pioneer High. So we infiltrate about 40% of the water that passes from the Edgewood neighborhood, the Snyder neighborhood, from Pioneer Woods. That all gets held up a little bit here. And if we can hold up water even just for a half a day, when it rains really hard in an urbanized area, that water is going to show up at the bottom of the hill after the rain that fell on the bottom of the hill goes away. So the idea is hold it up just for a half day, a day and a half, and then release it more slowly. So right now, we've probably, as a rule of thumb, in a developed area, you need 5 to 10% of that area doing your stormwater management work for you if you want to handle what's called the 100-year storm. Little tangent, there's really no such thing as a storm that only happens every 100 years. That's just an oversimplified way of saying statistically, somebody's done math that I can't understand to say there's a 1% chance in any given year that we'll get this amount of rainfall. So around here, that number is 5.1 inches, has got a 1% chance. That stuff's out of date. I don't know enough about the math, but I know what I see. And we've had 3 events in the last 5 years that are bigger than, what they say is maybe a 0.5% or less chance of occurring in a given year. So I don't know the right answer, but I know we need to provide more storage and capacity. So again, we're doing large basins and we're maybe getting about 10% of the issue dealt with in these large storage basins. So on site is the best way to do it. So we're going to talk site specific. There's about 30 little ponds for developments. When I say little, some of them are a couple of acres. Some of them are a dry area where water just soaks into the ground. But this is the area around that State Street going north-south, the State Street interchange. These are some legs of Mallett's Creek. So you sort of get an idea of this area, pretty developed and newer development. So there's a lot of detention basins, but on the right side, older development, not so much storage. How do we deal with that? We've got some basins downstream that we've retrofitted. You can go ahead and move ahead, Jim. All right. Jim's a steward for us. We count on volunteers a lot. As I mentioned, we do special assessment work and for a lot of maintenance of these areas that are more and more naturalized because the natural environment does a great job of dealing with water. It really helps us to have volunteer stewards. So site specific, there's basically 3 situations in a development. Either there's no basin because it was predated things like I was showing in that example where we did a regional. There might be an old basin that wasn't doing as much work in smaller storms and was also designed for what people thought rainfall was at the time, and we know it's more now. And then we've got new rules we established in 2014 that require people to soak water into the ground, 90% of the annual rainfall, unless they can demonstrate to us there really isn't any way to soak the water into the ground. If they can't soak water into the ground for a new development, we have them bump up 20% from what the calculations tell us. I know the storms are getting bigger. It's really hard to predict how much bigger, but we've told the development community since 2014, and we worked with them as stakeholders, you're just going to have to bump things up if you can't soak it into the ground. So those site-specific things are maybe doing 3, 4, 5 times as much work as those large regional basins. A lot of people think, oh, if we build a big thing, that'll solve the problem. But again, water is something that's dealt with at the source. So those are the things I mentioned. Here's a scatter plot. All the green dots are where people have been able to soak water into the ground. About 50% of the almost 300 developments since 2014 have been able to soak water into the ground. And again, 90% of the annual rainfall is a real benefit. We use sensors to figure out what's going on. We're actually doing a study now to take a look at our basins that are currently in the ground functioning as they were designed. Are they storing as much water as they can? But more importantly, where could we store more water? We're trying to figure out how to retrofit, how to, get a little bit more, squeeze that turnip. So we use sensors with U of M to figure that stuff out. Just keep plugging away, Jim. So there's also green infrastructure, people's homes. We have a lot of master rain gardeners. I've got a card out on the table with just some basic information. The next training course will be coming up here in January, February. So this is where there's 1,800 rain gardens throughout the county. They're very small. They don't do a whole lot, but many hands make light work, right? So Veterans Park, right next to the ice arena there. Nice big rain garden that has been doing a lot of work and has grown in nicely. And then the next example, Stone School Road along the top. The ditch is very deep there, 3 or 4 feet deep there. So we can have bigger plantings that are doing more work for us and helping out in Mallett's Creek. We have a little cut sheet. So our volunteers have a pretty good idea of what's the original intent. What type of plants are we looking to keep? And we actually will provide people with a photo guide, like you see in the bottom left, of like, don't pull this, pull these other weeds. So these are fun volunteer work days that I like to go see. And this is more the residential scale. So that's not huge, but that's dealing with the water from this home's roof. Soak that into the ground and we're all better off. Miller Road, there's 23 rain gardens. This one is very simple. That's called a fox sedge. There's just one kind of plant, 4 maple trees, and it's easy. And there's a lot of underground storage. All of these streets in Ann Arbor and Ypsilanti have some sort of soak the water into the ground because streets typically were not built to provide any stormwater management other than push it down the way. So in Ann Arbor, they realized we could do this underground. The whole downtown is a big sand sea. So these are areas where we've worked with road agencies to get more out of the public right away. Go ahead, we're just about done. So they can look pretty. The flowers don't flower year round. We do have to maintain them, and we typically go out a couple times a year. And then back to Mallett's Creek, there was a big plan back in 2000, and the next slide shows how just, you can't read all the text. The point is a lot of boxes have been ticked, and some of that has been done with grant money. And just a couple of more slides at the end here. So there you go. Thank you. We'll get this presentation over to the communications team so it can be available. I'll also include a link. We've done an analysis of equity spending that our office does. So we understand in neighborhoods with whatever demographic we want to screen for, we understand, are we spending disproportionately in areas where people are having a tough time? That's our goal. And the fact is we spend about 45% over on the east side, where we've got about 20% of all of our infrastructure. So that maybe doesn't solve everything. That maybe is just sort of a yardstick, but we want to make sure that we're aware of what we're doing so we can be mindful about how we do it in the future. So, Teresa?
So interesting. Thank you so
Yep,
much,
fun
Evan.
stuff.
Yeah. Wow. Well, we don't,
Yep.
I would love to do an entire, we need 2 or 3 times as much time on your work and other environmental and climate work. So let's, we can't do questions today because we have a long, as you can see, a big panel, but thank you so much. It was really, really fascinating.
Thanks, everybody.
Thanks.
Always available.
Thank you. Really great. Thank you so much.